did the whole process. We can figure out the end behavior. We can find our zeros. We know if we bounce or go through at each zero. We can find a y-intercept and put all that information together to draw your graph. This next piece is rational functions. So a rational function is when you actually have two polynomials being divided. You will need a graphing calculator for this section. So if you don't have one, you might grab one off the counter. This part, I'm going to give you kind of some background. It's up to you if you want to write this stuff down. I posted a handout on Classroom that has all this stuff typed up for you, so you don't have to write it down. You could just make yourself a note that pull up the handout in Classroom if you want. So I just took all this and typed it up and put it there, and I figured if I printed it out and gave it to you, some of you might lose it, so Classroom would be a place where you would never lose it. So, a rational function, like I just said, is just when you divide two polynomials. We do have to make sure if we're dividing them that the bottom isn't 0, so that q can never equal 0. When we graph these, we are going to have a lot of the same components as before. We can find x and y intercepts, but we're also going to have to pay attention to asymptotes. That's going to be the new piece here. So if I ask you for the domain, when you have a fraction, if I ask you to worry about the domain, what are you looking at? What can't happen in a fraction?
It can't be 0.
Denominator can't be 0. So let's just look at some rational functions and we're going to find their domains. So I'm just looking at when their denominator is 0. So when I'm looking at these, if I ask for domain, you are not paying any attention to the numerator. You are just looking at the denominator. I know x plus 5 cannot equal 0. So that means x cannot be negative 5. So how do you write your domain?
Negative infinity to negative 5, parentheses, divided with negative 5 to infinity.
So anything except negative 5 would work. Alright. I'm looking at this one. I know the denominator cannot equal 0. So what would we do here? There's more to it though.
You add 4 and
If you add the square root, what else do you have to put? So x cannot be plus or minus 2. In the past, if it's more than one value that x can't be, I've allowed you just to list them, so you can continue that. Just tell me x cannot be either of those. Let's see. If I go try this one, x squared plus 1 cannot equal 0. So x squared cannot equal negative 1. What happens if you add a square root on this? You get an imaginary. Am I worried about imaginaries when I go to graph these?
No.
So what's my domain?
Negative and negative positive.
Right. What I just found is the bottom never actually equals 0, so our domain is everything. Okay, D. I'm looking at this one. My denominator is 3, so I know that can't be 0. Does 3 ever equal 0? So what's your domain?
Negative.
When we graph these, asymptotes are lines that our graph approaches without actually touching. There are 3 different types we will look at: horizontal, vertical, and oblique. It is possible that somewhere along the line your graph may intersect a horizontal or oblique asymptote, but it will never touch a vertical asymptote. To look at a graph and see if we can pick out our asymptotes from this graph. So my domain. As you go from left to right, this graph is coming from negative infinity. Where does it stop? Kind of stops at 2. Then the next piece picks up at 2 and goes on forever. We never actually touch this 2. If I drew that vertical line there, we're just getting closer to it. We're not touching it. Our range, if I'm looking, this one we have a horizontal line that we're never actually touching. We never hit a y value of 1, we just get closer to it. So my range is going to be what? Intercepts. We have x and y intercepts. So x intercepts, where does this graph touch the x-axis? 1. If I wanted an ordered pair, that would just be 1, 0. Y-intercept, where do we touch the y-axis?
1/2.
1/2. Or if I wanted that as a point, it would be 0, 1/2. Okay. Horizontal asymptotes. That is a horizontal line that we're getting close to but not actually touching it. When you give me an asymptote, it is a line, so you need to write the equation of a line. What does the equation of a horizontal line look like? Y equals. So what's my horizontal? Y equals
2.
Horizontal.
1.
1. You notice that was where we had a break in our range values. What's our vertical asymptote? So how would I write that? You notice x equals 2, that's where we had a break in our domain values. Does this one have an oblique asymptote, a slanted line we're getting close to? No. Okay. Questions on that? So let's start talking about what gives us asymptotes. We've seen them in the graph, but what actually causes them? This is all in that handout I posted on Classroom, so you don't necessarily have to write it all down. If you do, I would just kind of summarize maybe these rules. So vertical asymptotes is what gives you 0 in the denominator. For horizontal and oblique, we have rules, and you just have to learn these rules. They have to do with the degree. So what this first rule is saying is really if the degree of the top is smaller than the degree on the bottom, it's always going to be y equals 0. If you have the same degree on top and bottom, divide the leading coefficients. If the degree of the top is bigger, there is no horizontal asymptote. Okay, so I haven't talked about oblique yet, and I will in a few minutes, but we're just going to start with vertical and horizontal. Vertical, it's just x equals whatever makes the bottom 0. Horizontal, if the degree of the numerator is smaller than the degree of the denominator, it's always 0. If they have the same degree, you just divide the leading coefficients. And if the degree on top is bigger, then there is no horizontal. So first thing, let's just practice finding some vertical asymptotes. Alright, so vertical asymptote is really kind of like finding the domain. When we did the domain, we were figuring out what x couldn't be. Those values that you get, that x doesn't work for the domain, those are where you have vertical asymptotes. So we really just need to figure out what makes the denominator 0. So if you add your 4 square root, but you have to do plus and minus, you get x equals plus or minus 2. So you could write it like that, you could write them separately. X equals 2 is a vertical asymptote, as is x equals negative 2. This one would have 2 vertical asymptotes. B, what's our vertical asymptote? 1, so we would write x equals 1. Since it is a line, you always have to give me the full equation. C, we looked at this one earlier when we did the domain. If you set that denominator equal to 0, and you try to do your square root, what happens? It's imaginary. So, is there a vertical asymptote? No. D, what would I need to do on the bottom? What multiplies to negative 21 and adds to positive 4? So what are your asymptotes? Questions? Alright, so are you guys comfortable with finding vertical asymptotes? Let's find a horizontal asymptote. Okay, so to find the horizontal, what we need to look at is the degree of the top and the bottom. Degree is the highest exponent. So what's the degree of the top? And the degree of the bottom? Okay, so look at those rules. We said that if the degree of the top was smaller, we have a horizontal asymptote, y equals 0. So this top has a smaller degree than the bottom, so it's just y equals 0. Before we do more of these, I want to go ahead and talk about what gives you an oblique asymptote. Oblique asymptotes happen when the degree of the numerator is 1 more than the degree, typo here, of the denominator. So if the degree of the top is 1 larger than the bottom, that's when we get oblique. To find it, we will do long division. So we have all these rules, and I told you that the degree on top was bigger if we didn't have a horizontal. Now I'm telling you, if it is exactly 1 bigger, you will get an oblique. Practicing finding asymptotes. When I look at this one, what is the degree of the top? 4. If it's multiplied out, you just take the highest one. The bottom?
3.
So the top is bigger, can it be horizontal? No. It's exactly 1 bigger, so what kind is it? Oblique. Okay, so to find an oblique asymptote, we are going to do long division. The numerator goes inside. I'm going to go ahead and throw in, I don't have an x cubed, so I'm going to put a 0. And out here we have x cubed minus x squared. I'm going to throw in the 0x. Now the nice thing is, we aren't going to have to do the full long division. An oblique asymptote is a line. We just need to get the equation of a line from this. So a line is y equals mx plus b. So we need to get our x term and our constant, and we'll have it. When you do long division, you do first coefficient. So it's 3x to the 4th divided by x to the 3rd. So we have 3x. And then what do? You multiply. So 3x times x cubed is 3x to the 4th. 3x times negative x squared is negative 3x cubed. 3x times 0x is 0x squared. 3x times 1 is 3x. Then what do? Change your signs and then add them together. Okay, so when I do that, my x to the 4th drop. We get 3x cubed minus x squared minus 3x. We almost have all that we need. You're back to the division step. What's 3x cubed divided by x cubed? 3. That is all you need. You can stop. So it's just y equals 3x plus 3. So you have to do the long division, but you are only getting the x term and the constant term. You don't have to keep going and find your remainder. Questions right there? Do you remember your long division? A little bit, vaguely, tried to forget it, but. Alright, same directions, we're just gonna look at more problems. So the degree of the top is 2, the bottom is 2. If it is the same degree on top and bottom, what type of asymptote is it? Horizontal asymptote. So horizontal is y equals. And what you do, if it's the same degree, you're just dividing those leading coefficients. 8 divided by 4 is 2. Really, all of these asymptotes are related to long division. If I set up the long division here, when you do 8x squared divided by 4x squared, what do you get? 2. And that's your constant, so that's your only term. When the top has a bigger degree, so like if I gave you x cubed over x squared minus 1. If you set that up to divide it, oh, I didn't mean to do bigger, I meant smaller. Okay, my rule, I told you if the top has a smaller degree, it's always 0, right? If you went to divide this, can you do x divided by x squared? No, 0, because you can't divide it. So really, all of those are related to the long division. It's just that the only one we really have to work it out the whole time for is the oblique asymptote. So that's kind of where those rules come from. All right, this one. What's it going to be? Horizontal. Degree on the top is 1. Bottom is 1. So same degree means divide leading coefficients. So we get y equals 3, just like 3 over 1. What's the degree on the top? Bottom? 2. So what do we have to do?
Long division.
Long division. It's oblique. Okay, x cubed divided by x squared. So just divided those first terms. Once you get that, you have to multiply. So I have to take x times all of that.
Switch this on.
You want to essentially subtract it off, so best option would be to change all your signs and you can just add them. Do that. My x cubed drop. 0x squared and 5x squared would be 5x squared minus my 6x and my 8. 5x squared divided by x squared is 5. And that's all we need. So we can say it's oblique y equals x plus 5.
So you have to say that's oblique or this
Yeah.
one.
Alright, I'm going to put a few up here for you guys. Same direction. Find horizontal or oblique. on top is smaller, it is horizontal, y equals 0. That was the first rule. Okay, B, degree of the top is 8, the bottom is 5. With the horizontal, I said if the degree of the top was bigger, there's no horizontal. With oblique, we said that happens if the top is exactly 1 bigger. And it's not exactly 1 bigger. So this one has no horizontal or oblique. C, the degree on top is 2, bottom is 5. So the degree on top is smaller, so that means it is horizontal, y equals 0. Are we doing okay with these? I think that is going to be our stopping point. We'll wait and do the graphing stuff Monday. So, yeah. The vertical, you would have a vertical on every problem. I just really didn't ask for it. So, let's say I gave you this one. And if I said find all asymptotes. Vertical, you have to check on every one. If I just said find all the asymptotes, you have to figure out what makes the bottom 0. So you would need to do your box method here. Multiply to 3 and add to 4. So your vertical asymptotes would be x equals -3, x equals -4. And then you have either horizontal or oblique. So if I look, the degree on top is 2 and the bottom is 2, so what does that tell us? Horizontal. If they have the same degree, you divide leading coefficients. So it would be 2 over 1